Um, is that right here? Okay, 1F, standing at the angle. All right, that is not the tangent ratio, is it? Nope. What is that?
Sine.
Thank you. It's the sine ratio. So, thank you for calling me out on that. So it is the sine ratio, isn't it? So on that sine ratio, instead of the tangent ratio, isn't it? Okay. As always, as I said, I'm working on these keys in between classes and all that. So it is the sine ratio. I made a mistake. So second sine, right? It's the inverse of sine. It's still what 30 over 53 though, opposite over hypotenuse, and as we go to that calculator of ours, okay, as we always just try to get into good habits of doing, as you open up that calculator for the day, my board sometimes does revert back. Nope, it did save it. So second what sine we said, right? 30 over 53, and what do we got? Not 30, but 34. Thank you. 34 degrees. Okay. Keep going. Other questions from yesterday? This is your time to ask about. Oh yeah, Eric. 2A. All right. Let's look at 2A. All right. Think there's a mistake there, Eric? Or just have a question?
Yeah, I think on cosecant B it should be 5/4.
It
5
should, Eric.
fourths.
It should.
All right, Eva. All right. Well, I'm looking right here at least, so I can at least tell maybe if I did screw up, maybe I get that first part right. All right. So I'm hearing very loudly from Eva. Eric was very nice about it. All right. Sine of E. I'm hearing something about the E's messing up. So first off, as we're doing our reciprocal functions, I showed my originals. I always like to do that for myself. So I'm here I messed up something maybe right around here with the cosecant of E. So first off, again, if I'm asking the cosecant, I'm going, no, I'm not going to cover anybody's class. That's not that. Hush, hush. Oh, all right, will do. Thank you. Spencer Nelson, I have your phone. Yeah. Yeah. I'll get you past in a second. Okay. All right. What's that?
He lost his phone.
Get out your books, guys. Yeah. Yeah. Spencer. Get out your notes, turn to lesson 5, I believe, is what we're on. Alright, so get down a little bit to secure desk, get that. What do we call it? Flip phone, right? Yep. Flip phone. When you come back, just go down on the desk, so I can write your hand on that. So, alright, what did I just say? I think it's lesson 5.
581.
What page is that? 581? 9, thank you. 589. All right, 589 I heard, lesson 5. So what today is kind of wrapping up a lot of everything we've been talking about. And as we do that, 589 here, let me bring that up with us. Okay. And what we'll be looking at here today is, again, kind of a wrap-up type of lesson, which is kind of nice. Everything we've been looking at. So on here, the first thing we're going to do here is kind of actually the very last question here, which is a nice one. It kind of brings back together all of our ratios with the special rights. So on that, we're going to get ready here in just a moment and write all those ratios with our 2 special rights. And we're going to create basically kind of our trig tables with the special rights. And remember last week at some point, I had thrown out there the trig table, and those trig tables are pretty massive. And the two special right triangles that we keep doing right here. So turn it to this page now. Find me that table, which is 593. Okay. These are our go-to special right triangles. They ain't gonna ever leave you. So as you roll into, again, next school year, if you go on to physics at some point, These are, again, three very special angles up there, 30, 60, and 45. And at some point, you're going to just start to remember those specific ratios. So what I'd like you to do is I'm going to put a couple minutes on my timer here. I do want you to go through and set those ratios. Standing at the 30, writing the sine, cosine, tangent. I would do those first, and then all we know after that is what? Cosecant, secant, and cotangent, those specific ones, right? So what I want you to do is, I'm going to give you maybe a minute here. Go do the 30. We'll come back around and check it. And then we'll come back around and check it. We'll talk about the 60, and then we'll talk about what? The 45. So, give you a quick minute. We'll make it 2 minutes. All right? Go do it. It's going now. All right? Go, go, go. Just do the 30. All right? So do the 30. Write the ratio as always in simplified terms. Now, what's the first thing that jumps out to you though? At 30, triangle. Do I have any sides? So let's put a side out there. If you're still already kind of struggling here, I'm going to pause that. Give me a number. 1, right? Throw a number out there. You can use a variable or you can use a number. If the short leg is 1, what's the rest of that triangle got to be? 1, this is going to be what? And the other one's going to be what? Now you're solid. These are all similar triangles, right? I heard somebody say 2. If I made the short leg 2 root 3 and what would happen eventually? It's all going to reduce that back down to right here, isn't it? Spencer there?
Yep.
Should we open the door?
Nope.
I gotcha. Okay, so now go back at it. If you don't have something there, just throw a number in there. Okay? Go. Now go at it. I think you should too. I know. They are not very nice. They are not very nice. I
That would have
said
been cool in the hallway.
you're not cool in the hallway. You're not cool in the classroom though. All right, Spencer. Spencer, we're on that page. I think it's 593. Okay. All right. Again, I'm just doing the 30 here. I'm asking you to do. Might take about 2 minutes or so. If you want to go on to the 60, that's cool. It's up to you. All right. We'll come back around and talk about here in just a moment. So let's make sure that 30 is correct. So on that 30, let's run it. Let's see what you guys got on the 30 across that row. So the sine, cosine, tangent, again, those should be immediate. You should know those. I'm never going to give you those ratios. I'll give you the formula sheet if you remind me. All right, sine ratio. Sine ratio stand at the 30. Let somebody have the sine ratio real quick. 1/2. All right. So sine ratio is opposite over hypotenuse. 1/2. What's somebody got for the cosine ratio? Root 3 adjacent over hypotenuse. Root 3/2. Tangent ratio. opposite over adjacent. Now I heard root 3 over 3. First thing you had was what though? 1 over root 3, right? So thank you. What that final answer is, Carter I think said root 3 over 3. But you first probably started as 1 over root 3 and then you rationalize, right? So that's again where I'm going at. And as you rationalize, that's the final answer I'm looking for on the tangent ratio. So that's again what we want. Eventually, you're going to have those memorized. Maybe already you do. Cool. If you don't, I don't care. That's fine. We can still find them out. All right. Now you have the original 3. Get me my lesser known cousins, the reciprocal functions. Okay. Again, the first kept and obvious one should probably be the tangent goes with the cotangent, t with t. So what? Root 3 over 3 becomes what? 3 over root 3, or go back to the original. What's the cotangent then? Reciprocal of that can be just root 3, right? Somebody just get root 3 there? Because it's the reciprocal of tangent, right? All right. And these are the two then usually students mess up with. If the mess ups happen, it's just because they forget which one goes with which. I always remember, again, S goes with C. Reciprocal of sine. 1 over 2. Yep, 2 over 1, which is just 2. S goes with C, C goes with S. 1 over cosine, right? All right, that one sucks. Why does that one suck? You got to rationalize. And again, I know most of you are getting to the point where you can just see that in your head. Cool. If you can see that rationalization in your head, go right at it. 2 root 3 over 3, I believe. And if that's not the case, show me that work. And eventually you get that 2 root 3 over 3. Yes, no? Okay. All right, let's go. We're going to give you a minute here before we do the next 2 rows. If you haven't done so, throw me the 45. What are you going to throw on the 45 then to help you out? 2, 2, 2 root 2, 5, 5, 5 root 2, 10, 10, 10 root 2, or go easy and just say 1, 1, 1 root 2. I could use our formula, our general formula. S root 2. It's the same thing. Those S's are going to reduce down. I like to use a 1, just again, go even easier. Any of those are going to work for us. All right. You can go turn to your desk, work with your buddy. Let's go. I'm going to put on there another, throw it out to 3 minutes. Fill me out those. Both rows. Both rows if you haven't done so. If you have. Try to make it quick there so we can keep going to the notes.
She's like, oh, surprise. It's the first one that's
Oh, gotcha. You just want to be. Yeah, it doesn't matter.
Yeah, I'm gonna try and figure out.
Okay, yeah, like Oakland. Mr. Fresh, can you guys hear real quick? Okay, I'm plugging this in. I just no people have thought it was. Just telling you. I've had multiple. It's fine. I was talking about him
So-
too, about how bad he is.
When you see the buttons appear at the bottom of the screen, this part of your calculator.
I don't think that's my Wait, what?
I saw you messing with it. So we have to use these buttons. So these buttons correlate to the buttons. So quit.
What'd you do?
I guess
You messed up my cat. How do you make like?
It is your bad.
Okay, yeah. I'll try first. What did you do? I don't know. How did you do it? I don't even know. I got all the saves.
I got ready to go.
I always one over two. Because if I go to the first one, then I may or may not have to rationalize. If I go with that second one, I think I'm going to have to rationalize. Thank you. All right, let's run through it here, where your brain can't process. Some people's brain just can't process like that flee or fight type of thing. And I had this. Some people had this like thing like they almost like jump. And that's where and I start to like really freak out. So yeah, it is. It's a terrifying thing. When I go up to Sears Tower, I put in some earbuds. Yeah,
I've only been there once.
I really, even the airplane. Like I know in the airplane it's not going to be bad.
Oh no, I
I
always
know
think
the
it's
static.
gonna
I know. But I have to put earbuds.
Turbulence, I like it freaked out.
Oh, I know. Like whenever you do that little drop, I think I just dropped it without feet. I know you did. So, all right, let's go here. Where's the variable going?
Right there.
All right. Where's the variable going? Let's read through this on this hot air balloon. As a hot air balloon does come in, actually a lot of times a hot air balloon will come in at an angle. Okay. So as we're reading through here, they're talking about our keyboard of that angle of depression. So as we keep talking about the last few days, an angle of depression, we all have this imaginary what? Horizontal line, right? So this imaginary horizontal line is where you're looking at, it's coming down to its landing zone. And that angle of depression is below that horizontal line. So that's why they're showing that 15 degrees below that horizontal. Now, as they draw that triangle, they drew their triangle, right triangle kind of inverted, which is totally fine. So they drew their right triangle a little bit inverted. They did not draw theirs straight down to the ground. Who cares? Okay, it's the same thing. So with that, their triangle is just a bit inverted. Cool. But how far is the balloon from the landing zone? So a hot air balloon, you gotta guess, kind of realize that usually hot air balloons do come in actually a bit at an angle as they come in, and then they will land. They don't always actually come in and then go straight down. So when the hot air balloon comes in to land, what does that represent in our triangle then? The legs or the hypotenuse? So that's where my variable's going. So there is in these application problems, just a little bit of, you gotta know how things, I guess, work. Once we know where that variable goes, nothing really to it, okay? What do we have standing at that angle? Sine, cosine, r, tangent. We got sine, so let's go set it up. Sine of what?